Let us now talk about a trickier question on prefix sum. This time we are given n ranges, and these ranges are given as two arrays, and we need to find the element which appears maximum number of times in all these ranges. So let's understand this question better. So this Li and Ri, or L0 and R0, they together represent a range. 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 So the ranges are 1 to 5, 2 to 8, 5 to 7, 15 to 18. We may assume that Li is going to be smaller than or equal to Ri. So the ranges are 1, 2, 3, 4, 5. 2, 3, 4, 5, 6, 7, 8. 5, 6, 7. 15, 16, 17, 18. Now if we take a look at all these ranges, which element appears in maximum number of ranges? So the element is 5. It appears in 3 ranges. There's no other element that appears in 3 or more ranges, right? So 5 is the most frequent element among all the given ranges. That is why our output is 5. How do you solve this problem efficiently? So a naive solution, you traverse through all the ranges, then for every range you you make a hash table or hash map where you store every item. Then you traverse through every range, other ranges, and increment the frequency of every item, right? This solution requires how much time? Say there are n ranges and every range has m elements, then it's going to take n into m time, right? If every range has m elements, or if m is the maximum number of elements in any range, then it's going to take big O of n into m time. So we'll traverse through all n ranges. For every range, we'll create a hash table, put its traverse through every element, increment its frequency in the hash table. So hash table has the time complexity of insert and search and delete as big O of 1. So you can insert every item in hash table and increment its frequency in big O of 1 time, right? So that is how you get the time complexity as big O of n into m. Can you do it in better time complexity? If you are given that the values in these ranges are small, the values in these ranges never go beyond say 1000 or 10,000. So if you are given that all these ranges have small values, this 18 is the maximum value here, and in general we assume that the maximum value never goes beyond 1000. Can you optimize this solution? I just told you a hashing based solution, then I said what to do if the ranges are limited. So what do I mean by ranges are limited? Li, Ri, they are smaller than 1000 and greater than or equal to 0, right? So if you have these values, can you do this solution in better time complexity? Can you solve this problem in big O of n time, right? Can you solve this problem in big O of n time? If you don't know big O of n solution, which is really a tricky solution, it's not easy to guess. What you will again think is, okay, I'll traverse through every range, make an array of size 1000, increment the frequency of every element by traversing through all the elements of every range. The trick here is, we don't want to traverse every element of every range. We only want to traverse through all ranges. And we want to use the prefix sum technique to solve this problem in big O of n time. So what we do is, we make an array of size 1000, right? I have created a vector. All the values in vector are initialized by 0. Default values are 0. That is why I've used the vector, not an array, to avoid that extra line of mem set and all, right? If you are a Java programmer, you can use an array list of size 1000, and array lists are also initialized as 0 values, right? Now this array ARR, which is actually a vector, this is going to have initially every range stored as presence of the beginning element and presence of the last element. Where does this range begin and where does this range end? So what I have done is, I have marked presence of every element. So I first mark presence of beginning of every ranges. So 1, 1, 1, right? I simply do this part, Li plus plus. So all these two things should happen together, but I've written step by step here. Now what I do is, I go through every range and mark the end of this range, right? I mark the end of this range by subtracting 1 from array of Ri plus 1. I subtract -1 from this, right? Why do I subtract -1 from this? Because if I do a prefix sum of this array later, I am going to have frequency of every element exactly stored in this prefix sum. That's the trick. So if you take a look at this array at the end, this has frequency of every element. Array 0 has frequency of 0, array 1 has frequency of 1, array 2 has frequency of 2, array 3 has frequency of 3, right? And you can see that 3 appears 3 times in all the ranges. In first range it's there, in second range it's there, in third range it's there. 4 appears 2 times, it's there in the second range and third range. 5 also appears 2 times, it's there in the second range and third range. 6 appears 1 times, it's there only in the third range. 7 appears 1 times, it's there only in the last range. 8 and onward elements do not appear, that's why we have count zeros for all the remaining elements. So this is actually a 1000 size array where all the remaining values are 0. How are we getting these counts in the prefix sum array? As I discussed earlier, we mark the presence of beginning of every range as 1. So if I do a prefix sum, and if I mark the beginning, all the values will be incremented by 1 after this element, right? Now we want to increment only till the end of the array. We do not want to increment other elements. So if there is a range 1, 2, 3, I'll mark its beginning at index 1 so that it is marked as 1. When I do a prefix sum, I'll have the sum of elements after 1 incremented by 1 because I marked the beginning. Now I do not want this increment to happen elements after 3. So if there is a range 1, 2, 3, the values from 1 to 3 should only be incremented by 1. Their frequency should be incremented by 1. That is why I decrease the value of Ri plus 1, right? So that elements after this index, after the end of this range, have values -1 subtracted. That is how I nullify the impact of incrementing the value, right, when I'm going to do the prefix sum. So when I'm going to do the prefix sum, I'm simply going to increment every value after this range. Since I want to increment only in the range, so I subtract a value after this range. So these two nullify each other. That's the idea of this algorithm. We increment the value of Li and we want to nullify the impact of this in the prefix sum array. So we decrement the value of Ri plus 1, right, at this index. Now I simply compute the prefix sum array for this array in this loop. I know the size of this is 1000 only, so I simply run through 1000, right? And while doing the prefix sum, I also check if the current value has the more count than the count that I have computed so far. And I store the index of this maximum count because that is what is my result, right? My result is index of this element which is having maximum count. So index is 3 here. For by chance the value is also 3, but we want to return the index, so we store the index. So to summarize the solution, we try to think in terms of prefix sum array. We build an array first which has presence of beginning and presence of end of every range marked. We use this array, compute its prefix sum. That's how we get the frequency of every element in all the ranges, and we return the maximum frequency. Let us now talk about more questions on prefix sum which are homework for you. So we are given an array. We need to find if this array can be divided into 3 parts with equal sum. Say the array is 5, 2, 6, 1, 1, 1, 5. This array can be divided into 3 parts with equal sum. Sum of this part is 7, sum of this part is 7, sum of this part is 7. You need to check if you can divide the array into 3 parts with equal sum for a given array. Next question is a very, very popular interview question. There are many, many variations of this question asked in interviews, and these 2 questions, next question and third question, they are discussed in the hashing track because they also require hashing together with prefix sum. So this problem has many variations. If I ask you this problem this way, that array has both positive and negative numbers, then this problem has a solution which is big O of n time and big O of n extra space. And if I tell you that the elements are only positive, there are no negative elements, then this problem has solution which is big O of n time and big O of one auxiliary space. Right, we'll talk about that particular problem in a different programming technique. So the third question, which is finding the longest subarray with equal number of zeros and ones. You are given a binary array, right, and you need to find the longest subarray which has equal number of zeros and ones. This question is very, very important. This has been asked in almost every company. So let me explain with an example. You are given a binary array. You need to find the longest subarray with equal number of zeros and ones. So your output is going to be 4. You can either pick these 4, or you can pick these 4, or you can pick these 4. But you can't get size more than 4. So your output is going to be 4. 4 is the longest subarray size which has equal number of zeros or ones, right? This problem is simply a variation of this, but with a little trick. Let me go back to question number 2. This question has many variations. You can actually be asked print the starting and ending elements of the subarray also. There I have also asked about only zero sum. So if I give you an example, I need to check if there is a subarray with zero sum. So if I give you this example, 6, 4, minus 2, 8, you have a subarray with zero sum, right? So there can be variations. Find if there is subarray with given sum, right, which is a variation of this question. One more variation. If I give you the sum as say 10, then you say there is a subarray with sum 10, right? So that's also a variation of the same question. So prefix sum technique that we just discussed has many popular interview questions. Some questions are directly based on prefix sum questions that we discussed in the beginning, the 3 questions that we discussed. In fact, the 4th question that I've written here, that's also based on direct prefix sum. Sometimes there are mix of 2 things, hashing and prefix sum. These 2 questions in particular, they are very popular. They require 2 things, prefix sum and hashing techniques together. So please try solving prefix sum questions yourself. On GeeksforGeeks, there is a tag called prefix sum. So if you open geeksforgeeks.org/tags/prefix sum, you will find plenty of questions which are based on prefix sum technique.